we're quite familiar with the shape ellipse. Can you tell me what an ellipse is? Right. If we have two fixed points, then an ellipse is the set of points such that the sum of their distances from these two fixed points is constant. These two fixed points are called the foci of the ellipse. We can also draw two axes of symmetry for an ellipse. This is called the major axis and this one is the minor axis. And this point equidistant from the foci is called the center of the ellipse. Take a moment and have a look at this ellipse. In this video, let's find out the equation of an ellipse. We know that for this, we will first have to draw the coordinate axis, that is the x-axis and the y-axis. What will be the simplest way to draw the coordinate axis here? Right, we can take the center of the ellipse as the origin, the x-axis along the major axis, and the y-axis along the minor axis. Actually, it turns out that the equation of an ellipse is simplest when the center of the ellipse is at the origin and the foci are on the x-axis or the y-axis. This is one of the possible orientations of the ellipse satisfying these conditions. Here the foci are on the x-axis. Another possible orientation is when the foci are on the y-axis and the center at the origin. So here the major axis is along the y-axis and the minor axis along the x-axis. Will there be any more possible orientations of an ellipse satisfying these conditions? No, these two are the only two possible orientations satisfying these conditions. So we will only consider these two orientations. Let's first find the equation of an ellipse for this orientation with the foci on the x-axis. Tell me, until now, what do we know about an ellipse? Yes, we know that for any point on the ellipse, its sum of distances from the foci is constant. Do you know what will be the value of this constant? It turns out that this constant will be equal to the length of the major axis. How? Let's see. Let the length of the semi-major axis be A, and also let the distance between the center and the focus of the ellipse be C. Now consider this point Q at one end of the major axis. What will be its sum of distances from the foci? It will be the sum of this distance QF1, which will be C plus A, and this distance QF2, which will be equal to A minus C. So we get this. We can see that the sum is equal to 2 times A. And we know that for any point on the ellipse, its sum of distances from the foci will be this constant 2A. And 2A is the length of the major axis of the ellipse. So we see that for all the points on the ellipse, the constant sum of distances from the foci is equal to 2A, which is the length of the major axis. We discovered one more thing about the ellipse in the previous video. There is a relationship between the semi-major axis, the semi-minor axis, and the distance from the center of the ellipse to the focus of the ellipse. Now, if we take the length of the semi-minor axis as B, then this is the relationship we saw earlier. So these are the two major things we know about an ellipse. Let's use them to find its equation. Let's take a point P on the ellipse with coordinates x and y. We know its sum of distances from the foci will be equal to 2A. So we will get this. Now since C is the distance between the center and each of the two foci, their coordinates will be C, 0 and negative C, 0. So we know the coordinates of these 3 points. Therefore, we can use the distance formula to find these distances. The distance between P and F1 will be this, and the distance between P and F2 will be this. So we get this equation. If we simplify it, we will get the equation of the ellipse. So let's quickly look at some of the important steps in simplifying this equation. First, we transpose this term to the right-hand side like this. Now we square the terms on both sides, which will give us this. Then we further simplify, we will get this relatively simple equation. Now we will again have to square both sides and simplify. Doing it, we will get this. Now notice this term a squared minus c squared. We can use this relationship to simplify it. If we square both sides of this relation, we will get this. And transposing two terms, we get b squared is equal to a squared minus c squared. So we can substitute this here, which will give us this equation. Here A is the length of the major axis and B is the length of the minor axis. So we found out that if P is any point on the ellipse, then its coordinates will satisfy this equation. Can we conclude from this that this is the equation of the ellipse? No, right? We know that we will also have to check whether the converse of this follows. That is, any point satisfying this equation will always lie on the ellipse. We will check this in the next lesson. We will see that this is the equation of the ellipse. To stay updated and to keep learning such interesting things, do subscribe to our channel.